everyone. So today we'll understand what are the terms naive and Bayes in naive Bayes algorithm. Okay. So first let us understand the word naive. Okay. So what is naive in naive Bayes algorithm? So the name naive is given, the term naive is given because of the assumptions of the algorithm. So naive Bayes algorithms takes two important assumptions. Let us understand those assumptions. The first assumption is every pair of features being classified is independent of each other. And the second assumption is all features makes an equal contribution to the outcome. Equal contribution to the outcome. So let's understand these assumptions with an example. So for example, you have a data set. Okay. So in that you have two features, color and shape. So based on that, you have to find out which fruit it is. So if the color is red and shape is spherical, the fruit is apple, right? So our first assumption says that all the features, that is, this is first features and this is second feature, right? So these features are independent of each other, means color has nothing to do with shape and shape has nothing to do with color. Okay. And the second assumption is that it makes is all the features make equal contribution to the outcome. Okay. So all the features are equally important. Okay. So this is why the name naive is given to this algorithm. The second thing why it is called Bayes algorithm. The term Bayes. So why it is called Bayes algorithm is because it uses the Bayes theorem. It uses the Bayes theorem. And what is Bayes theorem? Bayes theorem depends on the conditional probability. So let's understand what is conditional probability first. So probability of event A given that event B has already occurred. So what we can say that this is probability of event A given that event B has already occurred. So let's assume we have two events A and B. So probability of event A given that event B has already occurred, this is known as conditional probability. Okay, so Bayes theorem use this concept. So conditional probability A by B, A given that B has already occurred is given by the formula probability of A intersection B divided by probability of B. So let's understand conditional probability with an example. So for example, you went to a furniture shop to buy sofa set, right? So the probability or the chances of buying the sofa set is 30%. For example, 30% chances are there that you will buy the sofa set. But on the festive day or on the festival day or the discount day, the chances increases to 70%, right? So let's assume that probability of buying sofa given that it is a discount day. So this is conditional probability. Okay, so this is given by your conditional probability. So Bayes theorem uses this conditional probability. Okay, and with the help of this, we can derive that probability of A given B is equals to probability of A intersection B divided by probability of B. And we can also write probability of B given A is given equals to probability of B intersection A divided by probability of A. So we, as we know that probability of A intersection B is equals to probability of B intersection A. Okay, so we can equate the equations. Probability of A intersection B multiplied by probability of B is equals to, here we are only multiplying this to this, so probability of A intersection B. Whereas for this, probability of B given that A multiplied by probability of B is equals to probability of B intersection A. So these are equal. So we will equate this. So the equation will become like this, equals to probability B by A multiplied by probability of, sorry, this is probability of A. So probability of A. Okay. So probability of A given B is equals to probability of event B with the condition that A has already occurred divided by probability of A, divided by probability of B. So this is known as Bayes theorem. So because of the assumptions, we call the algorithm as naive. And because of using the Bayes theorem, we call the algorithm as Bayes. So the name is naive Bayes algorithm. So that's all for today.